Um, Welcome to the second week, like session for the course of the machine learning for engineering and science and the science application and all. In the first class, like in the first week, like last week, that we have seen the introductions and all, and we started with the that algebra how it will work and all. And today we'll continue with the algebra only, and then we'll go ahead with the like how it will going to start with the uh, so that one for like that one probability. So then that will not go too much detail of what we can say in the probability. Whatever it's going to use for our the course, so that we'll see, and then we'll finally go to the what we can say that the machine learning the portion and all. So in the algebra, if I'll see, I'll open the 1 minute. Go through the and I think for the last week content that I have uploaded on the website actually, and I'll show like how it will go and all. Machine learning. You'll be having the access for that also, and for another session also there will be a access for. So this is how you will get access here, and there also you can go. So that you will get the access for the both for the YouTube link also, and there will be content like whatever the PPT I'm using, so that also will be there, and so you can get the like if someone not able to attend the lectures and all. And in the first week, we have seen that is the machine learning, that is machine learning and all. And today we'll go a bit of basic of the probability, and then so first 3 week actually it's the introduction, and then we are going to like get the basics or maybe to make the like grounds for the what you can say like for the for the solving the machine learning problems and all. Just 1 minute. Anyone have the doubt from like like from the last class and all anything or something that we can discuss, or shall I go ahead and then I start my topic to like discuss and all, or anyone have the any doubt or that you want any that, or shall I go ahead with the discussions and all? I'll go ahead with the that discussions and all that we have seen until, yeah, in the algebra portion that we have seen like it's anyone have the idea what do you mean by norms? Anyone have the idea what is the norms actually? So so that the last class we have seen that norms is something that Uh, so the norms is the way of measuring the length of the vector. So in that also that we can get first order norms and then L1, L2, L3 that we can get it and all. And they are going to follow that standard of that linearity and all. And that before that, I think we have seen transpose and inverse. Like if you are well familiar with that our matrix portion, like it's going to follow what you can say that starting from the like the scalar, then vector and all. Because for the machine learning, there will be always that the input will be in terms of the numbers only, so that we can't give as a data like in forms of that image or any other forms of or any other. So that should be converted into the vector. So if you see for the image that I have discussed like in last class, like when we have any of the image, so that should be converted into the some sort of like matrix, and that will be the pixel will be there. And in terms of if it is black and white, so that one, and then otherwise it will be coded with the RGB. That's called the red, green, and the blue or the black, so that it will be their intensity number will be there. Then it will convert it into the that let's say for that it will be 32 by 32 that matrix 32 by 32 that matrix. So corresponding to the intensity that we are going to convert into the that called matrix, and we'll give the input to that one. In that only we have the definition of the norms and all is there. Okay. So in that only we have the so that the norms and all will be there. So so the vector norms will be there, that if it's going to follow that summation of that one, let's say we were having two vectors are there, one, two, V1, V2. So that the V1 will be so their magnitude will be V1 minus V2. And we can get similar to of the coordinate geometry also. Coordinate geometry that we can get it at. So if you see that one norm, like that will be the that is Euclidean form will be, it's going to get x1, or maybe that if it is v1 square plus v2 square plus v3 square, so on. So that is the one. Second one will be that what we can say we are having it's called two norms, because it's the terms will be that it's called two norms, and then we have the one norms will be there. So it will be double and v1, and then simply it's a summation of v1 plus v2. It's something called like that absolute value that will solve some problem that, so then we'll be able to see that is the how it works and all. So then like it's called u1, right? Then this will going to be up like let's say it's going to positive 2 3 till vn and all, it will be there. And then we have the p norms will be there, similar to that one only, like it's going to be a like it's so the one, then this is a two, then p norms will be there. It's going to be a v1 to the power p, absolute value of v2 power p, v3 to the power p. Then we have that what I can say infinite norms will be there, infinite. Then we'll have the infinite norms will be max of what you can say that will be having that v1 V2, V3. So just try to like get the attention. Like then, whenever they will ask you the norms, if it is going to be a one norm, so it's a that's going to be a like absolute summation of that whatever the value will come. That's like a scalar term and all. Whenever there will be going to be a two norm, means it's called the Euclidean distance and all. So it's going to be like that is called v1 square plus v2 square plus v3 square and all. Then if a similar way, if it is going to p norms, that's going to be v1 to power p, v2 power p, then it will go. And if it is going to infinite norms, it's called something called that is the max of the v1, v2, v3 will be there. So then we have the one concept is there is the linear combination. Linear combination of the set of the vector that is vector given by multiplying each vector by a corresponding scalar coefficient and adding the results. If you see that is the summation will be alpha I vi is equal to alpha 1 v1 plus alpha 2 v2 plus alpha 3 v3. So it's a similar like here only. So in general kinds of operation called the linear combination. Okay, so let's say we have one example is there. Just 1 minute. I think I should go with the diet. Okay, so this is how it will work. Sorry. Okay, so let's say we have one example is there. Let's say v1 is equal to 1, 2, 3, and v will be 2, 0, 3. I think till this or coming 1 week that will be a bit of fundamentals only. Then from the next week, like that will next to next week, we'll go with the solving. Like we'll go with that our neural that is network problems and all, and then we'll solve the actual that the machine problems and all. So then we have the span also. The span is actually is a vector of set of all vector obtainable by the linear combination of the original vector. So it's something like that we'll see once we are going to solve or we're going to write the code in the MATLAB and all. Then that the linear independence is something that a set of vector is linearly independent if none of this vector can be written as a linear combination of the other vector. By the name itself, that we have the two vectors are there that is the two vectors are there, but that is both are independent from the each other. So if we are going to write a that is a linear combination, but still but still that is not going to linearly like dependent. So that case we'll say that is linear independence and all. And one more thing that we have that is the metric that's the decomposition. Why we are doing the decomposition? Anyone have the idea? Why do we need to do the decomposition? I think if you have
So
to the
to reduce the dimensionality of any matrix.
yeah, if you see that example of the images and all, so that will be very high. The dimensional vectors are there, like it's going to be a 32 by 32, or maybe it's a like that's the high matrix and all. So that value we are going to decompose. So we have the single value decomposition will be there, and that is the eigenvalue decomposition is there. I'm just giving a brief that how it will work and all, and even that the people are doing with the norms also. Norms is also it's going to that's the one way to reduce the dimensions only because that we are coming up with the one length, and then trace we are finding out like that is summation of that all the diagonal elements and all, and then determinants also. So means it's that our aim is to like we should not complex or we should not. Uh, that increase the complexity of the model. We try to minimize or we should not give too much what you can say too much complexity to the model, it will going to cost in terms of that the demands of the processor and all that computational cost will increase and all. So that's why we'll try to as much as simple that input will giving to the that's the machine learning that model and all. Okay, so that the matrix decomposition we have seen that we have one is the eigenvalue decomposition. Then second one, what we have that is called singular value decomposition. So this is the two things that we have to do sometime because it's if you see that for any matrices and all like it will going to be a two then so 3 1 3 so it's the upper LVD or maybe the RVD that's going to be like it's based upon that how we are going to from the upper that the matrix terms and then that the lower that matrix terms will be there so that will be easy to get. So if you are not aware of this so that you can go through that first year mathematics will be there engineering mathematics so that you can solve through that one. So we'll solve some problem actually. Quadratic forms is there. Quadratic forms is something that is the second degree, but we can say that the norms only. And the only difference will be that we can get the positive, like when the values are okay. So now we'll solve some problems like till now what we have just introduced like how that is the algebra is going to useful and all. And now, based upon the algebra itself, we are going to solve that how the problem is going to work. So, please try to solve this problem like that. Let's say an autonomous vehicle data collected from the hundred like 1,000 times from a six camera and three. It's going to be some sensors is there. Uh, that's called lidar. That the yielding of thousands by nine. But we can say that the matrix, each row has the nine total cells. If you want to transform this into a single combined camera feature, a single combined camera feature, and two combined lidar feature. So it's something like we have output is something 1,000 into like three. So how come we are going to transform that one? So can anyone tell like how it will go? It's the simple that we are going to use for and anyone tell like how can we do this one?
सर m क्रॉस n मल्टीप्लाइड बाय n क्रॉस r तो n n कैंसिल हो जाएगा और 1000 क्रॉस 3 इसका आंसर आ जाएगा 9 क्रॉस 3.
Yeah, like something like whenever we are going to do the multiplication, that rule for the matrices, multiplication rule for the matrices, like it will be m cross n, and that should be like inner part that should be match actually. So n cross m or n cross p. So finally will be m cross p. This something like this will be there. So in that case also, let's say so 1,000 times 9 is there. So whatever we have to do, it should come 1,003. So this is going to match only. So only thing that we have, what we have to get like okay, 9. So here it should be 9/3. So that it will be that effectively that we should get like this. Whenever we are going to multiply 1,000 by 9 size of the matrices to the 9 by 3 size of the matrices, so that final bit get finally 1,000 by 3 matrix. Is it correct now? It's a simple that multiplication rule. Is it? Or any doubt is there in this? No, no.
Clear, sir.
So, uh, okay, so that the now we have the second question is there. Second question, can anyone tell like how we can solve it? They're saying like a 3 by 3 matrix of C A 3 by 3 matrix we have. Eigenvalue is L1, that is lambda 1, 1, 2, 2, lambda 3, 3 is there. So they're saying define a new matrices that where I is the identity matrix, which of the following could be the eigenvalue of the n. Can anyone tell like how can I proceed and all?
Sir, for the given equation n equals to 2c plus 3i,
Hmm.
first, uh, in the first time we put c equals to 1, uh,
Mm-hmm.
and I is the identity matrix which must be multiplied by 3. So
Yeah.
uh, ये यहाँ पे लैम्डा 1 लैम्डा 2 एंड लैम्डा 3 वन बाय वन हम पुट करेंगे और 2 से मल्टीप्लाई करेंगे मैट्रिक्स को, फाइनली दिस 3 से मल्टीप्लाई करेंगे आइडेंटिटी वेक्टर मैट्रिक्स को और दोनों को सम कर देंगे, फाइनली वी गेट द आंसर.
Fine. Yeah. So we'll be getting something like that is the case of what you can say. If lambda, if you go the one rules of the that eigenvalue and all, so for any given matrices and all, so for any given matrices, like let's say lambda is given eigen value of matrices, so then of A, so A lambda plus B is an eigen value of AA plus lambda I. No, BI. Is it correct? So that is the one rule that we have. So if we follow that rule, so N will become 2C plus 3I. So that is same will be case of 2 lambda 1 plus 3. That I will be that we going to identity matrix. So that N1, N2 will become like something 2 lambda 2 plus 3, N3 will become 2 lambda 3 by 3. So if we put 2 plus 2 into 1, like here 2 into 1, it become plus 3, it become 5, and 2 into 2 plus 3, it will become 7, and 2 into 3 plus 3 will become 9. So that our final answer will be 579. Is it correct? Is it correct now?
Yes, sir.
So can you solve the third question that we have considered vector in R3 that we have? So are this vector linearly independent or not? That we will tell. How can we approach this problem? Let's see when someone want to join also. How can we solve the problem?
Sir, in this case, we can write the u3 equals to 2 times of u2. So,
Okay, please solve and then tell the what is the answer for that.
yes. Okay.
So if you check for that, there one concept is there, like vectors for a given vector, for a given vector. Okay, so that should be linearly independent.
Sir, u3 can be written as 3u1 plus, no, no.
Going in some same directions only. Linearly independent if the solution C1 U1 plus C2 U2 plus C3 U3 is equal to 0. In that case, that is only possible like C1 is equal to C2 plus C3 is equal to 0. So that we can check it through how, like we can take the determinant. Like let's say we are going to combine this matrices 1, 2, 3, 4, 5, 6, 7, 8, 9. If it is km 0, so it means like that's going to be a this is not going to be a, dependent and all. So let's go with this 1, 9, 5, 45, 6, 8, 6, 48. So become minus 3, minus 4, and 9 into 2, 18, 8, 3, 24. So that become minus 6, is it? Plus 7, 6 into 2, 6 into 2, 5, 3. How much it became? 15. 6 into 2, 12 minus 15, like it's a minus 3. So it came minus 3 plus 24 plus 21. Wait. So it came 0. So means determinant of A is equal to 0. It means it's a linearly dependent. So that option will be B because the determinant of the coefficient matrices is 0. It's clear, I think. It's the properties of the matrix that we are following up. Like for a that is for a vector, if that is the linearly independent, so their solution of the coefficient of the matrix should be 0. That is the only case that is possible. Like C1, C2, C3 should be 0. Or either we can check through the we can combine into the one that is the matrices, and then we can check the determinant. If it is against 0, so it means it's going to be a linearly dependent. I think it's clear. Like, shall I go ahead?
Yes, sir.
Okay, so now what we have, that we have solved the problem. Like if the norm of the Z in the LP space is defined as a Z1P, it's a P here, Z2P, Z3P, and then all 1 by P, which of the following norms will be same value as the L1 norms for the Z? Can you just try for that? So they've given the Z minus 2, 3, minus 1. So determine the which LP norms gives the same value as L1 norms. So how can we approach this one? So actually, this is going to first hit entire method. So we're going to start with the L1 directly. So it's going to be Z1 plus Z2 plus Z3 will go like this. So it will become minus 2 plus 3 plus minus 1 plus 0 plus Z4. So how much it came? 2, 3, 5, 6 it will come. So now we'll go with the L2. Similarly, what is the L2? Can anyone tell?
Sir, under root के अंदर inside the under root square
Yeah,
of
yeah.
2 का square that is 4, 3
2
square
to
of 3
square,
9, square of
3
1
square plus 1
1
plus 0.
plus 0.
So it will be
So 4
4.
9 13 14 root over 14.
So 3.74 will come. So now we'll go with the L to the power zero point 0.5 also. So how it will go? It's going to be 8.5, 0.5, 0.5, 0.5. So how it will go? Root under 2 plus root under 3, root under 1 plus root under 0. So it will go like this. So how much the answer will come? And to the power, if you see that, if I am not wrong, we were going with the norms. I'll tell you like how, like norms. So it was Z1 P1 plus Z2 P2. Just 1 minute. Z2 P2, Z3 P2, Zn P to the power 1 by P. It will be there. So then after it was, if you go like this, zero point 0.5, so root under 2 plus root under 3 plus 1 to the power 1 by zero point 0.5. So root under 2, root under 3 plus 1 by 25. So it will come somewhere, answer will be some, like it will become the square actually. Root under 2, root under 3 plus 1 to the whole square. Root under 1 is something 1.414. Root under 3 will be 1.731. So 1, 2, 3, 3 into 3, like something it will come 17 and something will comes into the picture. 17. So that we have calculated, now we'll go with the L infinite also. Can anyone tell what is the L infinite? Normal of infinite.
It is the max of all value.
Yeah, max of
Individual
all value. So
values
there,
maximum. Absolute
so it will
value.
be, yeah, absolute value. So it is 3. So that L1 we got how much? 6. And then we calculated the L2 also. It came 3 point something came. We calculated the L infinite also, that came also. So it means that the L1 is none of the above actually. So that option 4 will be the correct option. Is it correct? Option 4 will be the correct option will be there. So now what we have, that the next question what we have is the, what you can say, they consider a vector A, their size of py1, B also py1. So they are saying let B is equal to I minus B A to the power transpose is the identity matrix of size P by P. Okay. So the simplest form in which the determinant of the B can be written as. Can anyone just try how it will go? And if anyone try like how it will go? There is a properties of matrix is there actually. Determinant of A plus U V to transpose. It's called determinant of A into 1 plus V to the power transpose A inverse U. So here A will become I and U to the power T transpose will become minus B A to the power transpose. Okay. So U will become minus B and V to the power transpose become A to the transpose. Okay. If you're going to substitute that one, so determinant of uh, B, determinant of B will become determinant of I minus B to the power A transpose. So how it will go into determinant of I into 1 plus A to the power transpose I inverse minus B. So 1 into 1 minus, actually 1 A to the power B, A to the power T is the VT actually. So A to the power T into B. So I think this will C is the option. Is it? No. So this is the one property actually what we have for any that determinant of what we can say A plus U to the power V U into V to the power V transpose is equal to determinant of A into 1 plus V transpose A inverse U. It's the decomposition vectors and all that will comes into the picture. And if you're going to compare with that, so A is actually what is that our I, and U V transpose is actually what we have, that is a minus of B A transpose, is it? So now if you see the U is equal to minus B, U is equal to minus B, V to transpose is actually A to power transpose. It like that's A transpose. If you're going to keep all this into that, what you can say, they have given the B. So now we take the determinant for that is for the both side. So that the determinant of B, determinant of A plus U V V transpose. So now what happened? So that's the determinant of I, because the A is actually determinant of A, determinant of I, one plus V to power like that's the V transpose. So A transpose and A inverse. So what we have, like, it's a I inverse, because A what we have I, and then what we have the U minus B. So 1 minus A transpose B. So this is the simplest form for the determinant. Is it okay now? Doubt is there, or shall I explain it again? Then please.
Sir, can we apply this formula for every question? Like similar question?
Yeah, similar question we can apply. Let's say they are given in this form, actually, they have given like uh, they have given determinant like any A plus U V transpose in any form they have given, so that we can apply. So we can just take, let's say C B is equal to A plus U V transpose. So just take the determinant of this and then apply this formula. We can apply for the any similar question also. That will be applicable.
Okay, sir, thank you.
So now what we have, the solution to the system of equation given by. So they have given that is that what you can say, one A x is equal to B, is it? So now they are saying to find out the x value. So x, how can we get x A inverse B? Or there is another way also there that we can get it out. Can anyone have the idea? It's called transformation of the matrices, like that is called row operation or the column of operations and all. Is it correct, no? Row transformation. Can you have the idea like how can you proceed and all? So first step is to get the augmented matrix. It's called A, B. So that's 2 minus 1, 3. 2 minus 1, 3. And 4, 3 minus 1, 1, 2, 5. It's the dot one, not the 1. 11 minus 7, 5. Can anyone tell like how can we proceed from here? So we'll try to get at which at maximum try to eliminate the number from the below. So now we'll perform row operations. Row operations. How come? R3 minus, or R2, we can go R2 minus 2R1. Can we go like this? So that this will get 0. We'll take one page actually. If you see that we want to get the 0 from this place, so R2 minus 2 of R1. So R2, what we have, 4 minus 2 into 2. So we'll get first row will be as it is 2 minus 1 3, and what we have 11. So if you're going to see like so, that will become 0. This will become R2 3 minus 2 into 2, like it will become how much? 3
7.
minus how
Uh,
much?
5, sir.
5. What about the next one? Minus 1, minus 2,
Minus
so
7.
minus 7. Minus 7. So how much it will become the next one? Minus 7, minus 12. So
Minus
it will become the
29.
minus 29. So third one will be the same. Third one, what we have? 1, 2, 5, 5. 1, 2, 5, 5. 1, 2, 5, 5. Now, which operation we can do? Now, R. Which one? 3. Is it?
R1
R3
minus
minus
R3 can be written as R3 minus half T.
half of R1.
R1.
Can we do it?
Yes.
Can we? So now that will be same only. 11. This also will be same. Minus 29. It will become 0. And the next one will become how much? 2. 2 minus minus half. So it will become the minus plus half. So 2 plus half. 5 by 2. Is it? Then 5 minus 11 by 2. Then 5 minus 11 by 2 minus 1 by 2. Is that? Is it? Now we'll do 3 is equal to R3 minus half of R2. So we'll get 2 minus 1, 3, 11. R3 we have to do 0, 5, 7 minus 29, 0. 5 by 2 minus 5 by 2, 0. 7 by 2 minus 7 by 2, how much it will come? It was actually minus 7. Is it? How much it will come? 7. And
7.
this will be, is it? So now that we can get, this will become 7x3 is equal to 14. X3 will become 14 by 2. 2. Is it correct or not? Because x1, x2, x3 is equal to whatever the terms will come. If you remember that, what you can say, this there is system of equation that problems and all. Ax plus b that we have done here only now. Ax is equal to b. So now we are going to multiply going with this. So how it will come here? So now second one will become 5x2 minus 7, 7x3. How much it will come? Minus 29. So x3, how much we got? 5x2 minus 7 into 2 into 29 minus. So 5x2, 29. How much is that?
Minus
Is
3.
it correct? Similarly, we can get for 2x1 minus x2 plus 3x3 is equal to F11. Can you tell the what will be the x3? No, x1. What is the answer for the x1?
1.
Yeah. So which option is the correct actually? We have the -2, then no, +2, -3, 1. So we have 2, what about it? 1, -3, 2, 1,
C
-3,
option.
2. C.
Hmm.
So now the next question what we have the consider two
Sir,
matrices P
excuse
and
me,
Q. Yeah.
sir, but it takes a lot of time, sir, to solve it.
Yeah, for assignment it will take some time, but for ends it will be similar way only. So that you can do with the different methods also. So mostly it will be like a tricky type question like this will be there. This type of system of equation it will mostly it will not there. If it is there, so you can do the some that what we can say that directly so that you can apply this values like you can keep first option and then try to get us all the that equations. Second option, third option, the similar way that we are doing for the gate and all, gate or some other competition examinations and all. So this is that something like a standard method that I followed. Okay.
We can directly solve this question for saving our time. Just we have to know the how to solve this problem. But
Yeah.
by putting the value of action x1, x2, and x3
Mm.
as given in the option, we can
Mm.
also solve this.
Yeah, yeah,
Check
yeah.
check this.
That would be easy actually, like to save the times and all. So just I wanted to look show like that is a standard method to solve the problems and all. Otherwise, that we can keep the directly value if it is came the same as it is the value that came the B. So it's correct, whatever it will come. Is it? If we solve, let's say 2, 1, 3, I'll keep here 0, 0, 0. So it will be 0. So that is not the correct option. Then I'll keep 1 minus, that's the -1, 2, that -3. So it will again will that not comes. So it will be like that we can do that hit and turn method. If we are going for the any university exam or anything, something that they need more explanation, so that we have to go through this way. Is it clear or either shall I solve for that the shortcut method also. Hopefully it will be clear. So now what we have that is two matrices are there, P and Q. For the P, that the size of 2 by 4, Q is the 4 by 2. So they are saying to the following operation are performed that is what you can say sequentially. First one is to compute the product P and Q resulting the matrix R. So X will be P and Q. So that will be the same. So we'll get 2 by 2 matrices. Is it? And is it? Now they're saying take the transpose of the R. R transpose will be again 2 by 2. Now subtract a 2 by 2 identity matrix from the RT. So let's say that I'll be taking like R transpose minus I. Okay. Multiply the resulting element wise Hadamard product with the 2 by 2 matrix S where all the elements are equal to 3. So if something will be 3 into R transpose I. Is it? Like first step is to multiply P and Q. So this was the 2 by 4 and 4 by 2. So that the resulting matrices will be 2 by 2. Now they are saying take the transpose of the resulting matrices. So it will be same. RT transpose only. Now they are saying subtract the 2 by 2 identity matrix from the RT. So RT minus R transpose minus 1. Now they are saying multiply the resulting matrix element wise with the 2 by 2 S matrix where all the elements are equal to 3. So 3 into R transpose minus 1. So what is the option? So A 2 by 2 that matrix is where each element is a multiple of 3. So that the B will be the option. Is it? Or that you want to see again? Anyone, please? It's clear or either some doubt is there? Please tell me. No?
It's clear, sir.
Yeah. So we'll go to the next question. What we have? We have the consider a square orthogonal matrices such that D transpose D is equal to identity matrices. If P is a column vector and Q is equal to DP, which of the following statement is true regarding the dot product QT? So that is a Q transpose into Q and P transpose into P. Can anyone try how it will proceed or not? So they have given D, let's say P and Q, PP. So let's go with the Q, T, Q. So DP transpose into DP. Is it? So it will become P transpose D transpose D P. So it will become P transpose I P. So eventually it will become P transpose P. So I think the option C will be the correct option. No, because Q they have given D to the power DP and all. So now we want to get the QT, no, Q transpose Q. So Q what we have DP transpose DP. So we can go with that how it will go P transpose D transpose D then P. So P transpose this already given as a I. So I P. So P transpose P. So this is the answer will be this C1. Okay, now we'll go to the last question for the algebra problems. They're saying consider a data set. Consider a data set of the videos. Anyone solve this problem? I'll wait for just 2 minutes. Okay. Then each video have the frame.
Sir, B option.
See, and each frame is having how much? 64 by 64 pixel. Then each frame having how much? Three color. So 200 into 30, 64 into 64 by 3. So our option will be second. It's correct, no? Like it will go in sequence way. We have the 200, that is the 200 videos, and then each videos have 30 frame, and then each frame have the 64 by 64 pixel, and then each frame also contain the three color. It's a RGB. So means 200 by 30 into 40, 64 by 64 into 3. So that total data set will be consist of this dimension. So that is the part of algebra that is completed. Now, uh, now we'll go with the what you can say that that is the next chapter. What we have is the probability. Okay, I'll just insert the cameo for all sides. Can anyone tell why do we need to study the probability in the machine learning and all? What is the need of that? Hmm? Because can anyone have the idea? No, because if you see the machine learning is going to trained on the some data set. Some data set will be going to be deterministic, and some data will be uncertainties will be there. To deal with the that uncertainties or approximation or estimation and all that we are going to deal with the what you can say. So that's a very important and all. And even with the making thresholds also, that will be very easy. So every time that our data will be not that deterministic and all, it's not there will always uncertainty will be there, or either we have to make some assumptions or either to make some pattern and all. So there's always chances. It's not the we'll say with like our very confident way. No, no, like that I can say, okay, this is going to happen. This so that will happen. No, that will say, okay, there is a chances of 90% that will going to happen. Or classification accuracy percentage is that much. It's something like it's something that's going to make some decision. So there will always uncertainties will be there. To deal with the uncertainties, so we should be having some basic briefing of the probability also. Otherwise, it will be trouble for us, like because that the many things, basic things will comes into the picture. Maybe like that the product rule, sum rule, or the base theorem also. Even we have that naive based like the classifier also there. So similar way, it came from the probabilistic model. It came. So that's why we should have the some basic brief idea. Even we have to deal with the variances, like how much that accurate or what is the difference between that accurate or like a predict that one predicted value to the actual value, how much variance is there, how much is the expectation and all that we should have the idea and all. So that's why we are going to make some sort of like study or we'll have some basic brief of that, and accordingly we'll go ahead with that. So if you see that the theory of the probability, so if you see the theory of the that is the probability, if an experiment is repeated under essentially homogeneous and similar conditions, so we generally will get the two types of the that is situation. So that the result, that is a usually known outcome. It's called deterministic. And second one will be the results are not unique, but maybe one of the several possible outcome. Let's say uncertainty will be there. So that's let's say that we have the perfect gas PV is equal to constant. So this is always a deterministic will be there. Or maybe that V is equal to U plus AT. Again, it's going to be a like deterministic and all. Okay. So that case, so first one will comes under the deterministic or predictable. That is something that is based on the science, based on the science and all will be there. If you see some sort of there's some phenomena which do not lend themselves to the deterministic approach. It's called unpredictable or maybe the probabilistic phenomena and all. So in concept of the coin, if we're going to toss the coin, we're not sure whether it will come the head or tail. We're not sure. So what will happen? It's going to be a uh, like probabilistic model. If a light tube had lasted for the T hour, nothing can be said in the further life. It may fail to function at any moment. It's that we don't have the certainty and all. In such cases, that we talk the chances or probability, which is taken to be the quantitative measure of the certainty. So if you see that one that I'll take in a similar way, if you see the some click, what is the chance that a leap year selected at the random will go into 53 Sunday? Anyone have the idea like how it will go? If you see in the leap year, 366 days. Is it? And if you take the 53 Sunday will be there, and then 2 days will be over. So there is a high chances that we'll get the Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Sunday. So they're saying like we'll get the 53 Sundays. One Sunday, second Sunday. So total 7 is there, 2 by 7. So there is chances of the two by seven will be there. So some sort of some theory of like we have the rules will be there or law. Consumer like commutative law, A union B, like A union B will be B union A, or A intersection B will be the B intersection A will be there. Associative law is also there. A union B, union C, A union B is going to union to C. Similar way, A union B union C can be there. Then we have the distributed law is also there. A union B intersection will be there. So A union B union A intersection C. If you draw the Venn diagram, then so that we can get it out and all. Complementary law also there. A A complementary, so it has become S. So A intersection A bar is become 5. Just 1 minute. Okay. So can anyone tell what is the base theorem? How it will go and all? Or either I'll go one. If you see that one, the probability is a mathematical framework for the representing the uncertainty. Okay, uncertainty will be there. And multiple sources of uncertainty, it will come in the engineering and science. It's an internal, that's called, just 1 minute. Randomness will come. Maybe we'll talk about the entropy and all. Then either incomplete data or observability, it's going to be give the that will not give the better results and all, or incomplete the modeling. So that also will comes into the pictures and all. So where we're going to use dual use of the probability ideas in the machine learning, that we are going to use constructed learning system, like we are going to incorporate where probabilistic algorithm by try to mimic the human reasoning about uncertainty. What we'll do, we'll be giving the like incorporate like the algorithm so that they are going to that the mimic without having an error and all. So that's the like naive based classifiers and all that we have. Even that we can use for the analyzing the learning system, how our model is learning, or either even deterministic learning system are only correct part of the time. So their output can be therefore analyzed probabilistically, like how well that our model have learned, what is the percentage, or maybe what is the accuracy and all that was there. So probabilistic analysis of the deterministic probabilistic model. So that's what we are going to use in that. So if we talk about in the machine learning, so we'll talk about the two terms, like a frequentistic versus the Bayesian. It will be the always the objective measure. Objective measure will tell like how depends upon the how, like proportion of the event in the infinite sample space or objective measures also. Bayesian is something called degree of the belief system. Like it will say, okay, that much there is chances of the Their chances of the rain is there. How much? 90%, 80%. That will not talk about the numbers, but here we have to talk about the numbers also. So let's say that is the definitions like how, like that the random experiments and all. So can anyone tell what is the event? Then we'll be having mutually exclusive event. Then we'll be having the independent event. Can anyone try to define these terms and all? Event is something that is, let's say, I'm going to toss the coin. So in that coin, either the head will come, tail will come. So that is the head is the event, tail is the event. But if you say that space, so in that space, that will be having head and tail both will be there. So that will say the random space, or maybe the random experiment will say. So that's how we have to define it actually. So event is something that we are going to having either head or tail, or if you say that random experiment or sample space, it's will going to all possible, like s belongs to all head, tail, and all will be there. So that's called all possible outcome of the random experiment. Okay. So let's say tossing the coins, it came head and tail. The sample space we choose depends on the purpose of the analysis. In the similar way, like we have to take the low, medium, high for the manufactured pipe. This could be the diameter of the pipe, maybe the low, medium, high, or maybe satisfactory or unsatisfactory, and all. It's all depends upon the how it will go. Similarly, that the random variable. Can anyone tell what is random variable? Useful to denote outcome of the random experiment by the numbers. Random variable is something like let's say that can be done even for the categorical, whether it's a spam, not a spam. It will rain, not rain. So it's all will comes into the random variable, or maybe that how it's going to associate it with that also. The variable that associate a number with an outcome of a random experiment, it's called a random variable. So that the random variable, like so let's say what is the probability of that rainfall is greater than the 10 mm. So probability of rainfall is greater than 10 mm. So it's become random variable. Okay. So this is like something that we're going to define with the some sort of numbers. And if we talk about the probability distributions also, so probability distributions that how likely a random variable is to take each of the possible sets. Let's say we have the one sets are there, it's going to 10 here, so to 5 here. It will make like this, make like this, make like this. So if it is x, how y? So if you will change the x, that how that the y will vary. So this is going to be a discrete one. It's going to be a discrete one. If we talk about like how it will go, so it's a continuous also will go. So it's a called continuous random variable. For this also we have the probability mass function. Probability mass function. For this we have a
Probability density function.
yeah density function will be there. Here it's area under the curve. Here also area under the curve only, but here we'll be having like p of x is equal to some point p of x is equal to 1, but there it will be, if you see that some rules will be there for a domain p is set with all possible state of the x, so there probability, it will be always going to be a 0 to 1 only. And summation of all the properties, it's going to be always 1. That so this is the one thing. And the uniform random variable, it's again 1 by k. It's again it will come like this and all, analogous to the point load. And then we have the PDF also. PDF will be, it's going to be a how? It's going to be always 1. Earlier it was a summation, now it become what? Now it become the integration. So it's actually a, they're going to plot like this, that a histogram density and all. So this is the all we talk about the random experiment, and then discrete variable. Then we came across with the that the continuous experiment, like continuous variable, and then for discrete we were having that, what you can say, PMF, like probability mass function. For the continuous we were having, what was we are having, PDF. So now we'll go ahead with that. We'll be having like independence, or maybe what you can say, Bayes theorem. Can anyone explain what is the Bayes theorem? Hmm? If we go here, that I will explain it here. Bayes theorem is nothing like we'll be having P of X by Y. So P of Y, is it? How it will go? Is it? It's a conditional probability which comes into the picture. Conditional probability will comes into the picture. Y. Here it is Y. X by Y. Huh. So they are saying here, what is the A in a bold factory? Just 1 minute. This is the question that what we have. In a bolt factory, machine ABC manufacture respectively 25%, 35%, 45% of the total. So of their output, 542% are defective bolts. A bolt is drawn at random experiment are found to be defective. I'll just remove this part. Okay, so in a bolt factory, ABC manufacture this much of total. Out of their 542% are defective bolts. A bolt is drawn at random from the product and found to be defective. What are the probability that it was manufactured by a machine ABC? Can you please try to solve this one? So if you go with the P of E1, it's a 25%, so 0.25. P of E2, it will come 0.35%. P of E3, it will come 0.4%. So they're saying the probability of the drawing a defective bolt manufactured by a machine A is, it will be something probability of E from first one, it's a 0.05. Similarly, from B, how much? 543 was there. 542. 542. So now you can apply the Bayes theorem also, and then so that you can keep the value here. So P of E1, getting it here, like it's a, hence the probability of defective bolts selected at random is manufactured by a machine A. So it's something will be there, P of E1 into P of E1 by E by summation of that all. Like summation of will be that P of EI, P of EI by E. So it will be P of E was how much was there? 0.25. When it become from the 1, it become 0.05. Now take all 0.25 into 0.05 plus 0.35 into 0.04 plus zero point 0.4 into zero point 0.0. This is how it will come. So that's how that we are going to apply the base theorem now. Okay. So then after what we have a random variable that we have seen around also. So now we'll go back to the our materials there. Now we'll come to the independence and all. Independence that the variable is something that will be having one variable is going to be a independent from the other. Let's say if they're going to toss the coin, toss a coin or throw a dice, both are independent. But if we talk about the height and weight, let's say for a human being, for a human being. So when the height is more, so that weight will be more. When the height is less, like it's a compatibly, like it's a dependent from the each other. It's not independent and all. So in the probability also, like it's with the p of x y, it's a independent of their probability. So this is how it will work and all. So independence is equivalent to saying P of y given x also P of y only, or P of x y given also P of x only. So it means one variable is not going to depend on the other variables and all. So that's how it will going to be like. So that we can apply it through the like a product rule also. P of x y is equal to P of y by x into px. Okay. So then we can get the P of x into py. Similarly, P of y by x is equal to pyy. This is how it will work. Now the conditional independence. If we're going to add one more parameter, so it will become the conditional independent also. Two random variable x and y said to be independent given if only if both are going to be like independent of her. So more precisely, if y x I are independent given if, how come? So let's say independent, conditional independent. Throw a dice, toss a coin, card from deck. Both are independent, conditional independent also. Not independent, but conditional independent. Height, vocabulary. So that age, with the age, it's going to be like independent. For that particular age, both are dependent only. For a particular age, for a particular age, for a particular age, given age, these are the independent, but not conditional, not independent. Dice throw one, dice throw two, sum of the dice. So it means independent. Throwing a dice one, throwing a dice two, both are independent, but it's a conditional, not independent. Because if we go through that, what you can say that in the multi-class classification or maybe that the multi-class features will be there and all. So that will be very useful to solve these things and all that comes in the picture. So that's a similar case we can get with the conditional probability chain rule also. So we were knowing that P of xy is equal to P of xy into Py. So now similarly we were having what we can say P of xyz. So now we can get a similar of P of x and y. So now we can solve similar way. So it's actually it will come P of z for given y by z and P of x y z. It's a something we are going to say chain rule. Chain rule that if you go to nuclear reaction will be there. So one then become three, from here four, five, six, here seven, eight, nine, similar. So it will go similar to that only. So that's how we'll tell chain rule of the probability. In general, if we are going to say, so P of x1, P of x2, 1, 2, P x xn 1 till until the n minus 1. So this is called chain rule of conditional probability and all. So then the next one what we have, expectation. Can anyone tell what is the expectation actually? Have you heard the name of the mean, mode, and then median? Have you heard of that? This all three coming from the classical statistic. Same thing if you're going to combine with the probability, so it's come, mean will become the expectation. Random variable by definition result in a different outcome. The variation that is a similar that is what you can say. What we have that the random variable distributions, that is a probability mass function for the discrete variable, probability digit function for the continuous variable. So in the statistic, I told that mean is actually expectation and variance to capture the sum overall properties of the distribution and the variable. So expectation is something that we are going to mean or aggregate from the all the event actually. So to capture the small properties of the small distributions and all. So if you're going to see, expectation will give the mean, average, expected value of the random variable given the distribution. So expected return on the certain investment in the market, expected run fall, it's actually a overall or average actually. So how we're going to like give the notation like expectation or expected values of some function respect to the probability distribution or the average value of the fx, and p is going to clear from the like e of x, f of x will be there. And if you're going to see the discrete, so expectation will be summation of px fx dx, or for the continuous it will be p of fx fx dx. So this is the whole about the discrete, and this is about the continuous. Then actually in the case of machine learning, what we'll be having, we'll be having the multivariate random variable. So it's in nothing. It's we'll be having x, x1, x2, x3. So now expectation of the full vector will be f of x in terms of vector only. So expectation of x1, fx1, expectation x2, fx2, similar to f of xt, fxt. Actually, this is going to be very useful when we are going to solve the numerical for the machine learning model and all. So maybe for now it will be a bit of boring, but once we go to the the writing the code or showing the problems, so that we're going to write to this all, because there will be having a that much more that the multivariate will be there. Let's say that what is the expected value of the coin toss for a fair coin, assuming the heads will be the 1 and tails will be 0. Random variable will be the 0 and 1, and P is a uniform distribution with the both having probability of half. So in that case, to get the what will be the 0 and 1, for getting the head either 0 or either 1, so it will be there. So then similarly will be for the other case also. Then we'll go with the linearity of the expectation. Let's say earlier we were going with the linear regression and all. Similarly, for the expectation also we have to follow the that expectation operation actually is the linear. So let's say if a function f of x is equal to alpha of f of gx beta h of x. So in that case, expectation of f will become alpha expectation of g plus beta expectation of h. So means its expectation operation is actually a linear function. Okay. Then that we can solve also similar way. Like how can we give the proof also? Like let's say we have the function of alpha e of f alpha eg plus beta eh. So e of f will go with the fx into px dx. Fx we know that alpha gx plus beta hx and hx. So now the alpha is the constant, so it will come out. Beta will come out. So but it is there g and h. So that can be done for the discrete also. Then the next theory what we have, it's actually variance. I'm just going with the flow only. Then we'll solve some problems also. So variance is actually till now what we have seen. We were till now what we have seen what is the continuous variable, what is the discrete variable, random variable. Then we have checked with the expectation. Now we are going with the variance. How the variance will look like. Then we'll go with the covariance. Then we'll solve some problems also. Okay. So variance is captured by the distribution. Let's say that we what we have. Variance is the give the variance from the expected value. Let's say this is the things like how well it distributed, or maybe one to how the vary it called. So variance also measures the amount of fluctuation of the variables. So variance in the return on a certain investment in the market, like it's going to a risk measure. Then variance in the rainfall during the coming that monsoon in the starting, how it was there in the mid, and then how we can compare with the from the last year, or we can do even with the forecasting also, or the forecasting done by with the IMD, whether it came or not, or how much the variance was there and all. So that's how we are going to define. So univariate, there is a univariate variance is something variance, and it is square root standard deviation of some function with respect to the probability distribution. Measure the how much value of the fx varies sample when x is down from the p. Something like we'll be having that when we are having the variance or its square root, it's called standard deviation. So they're saying that from the fx function, if you're going to draw the x, that how much the value of or how the probability got distributed and all. So that we can check with the variance of f. If we go with the MATLAB code, so we can write the variance of f, it will come into directly, or v also, f will come into picture. If you're going to simplify, variance of f x will be expectation f of x minus expectation of fx to the whole square, it will comes. And a standard deviation will be root under of variance. Okay. So covariance is something like when we have that the univariance only the either x or y. But when covariance will be there, we'll be having the two like x or y. So that we all know that v of x will be expectation of x minus x bar whole square, or x minus x bar x minus x bar. So that can be generalized through how come we can generalize that is the covariance of x and y will be the expectation of x minus x bar, y minus y bar, expectation of x minus expectation, y minus y, that like expectation of y. So similarly for the functions also we can do similarly way. This was the x itself, now is the function. Similarly we can do, and even with the correlation also we can check with the covariance of xy into variance of x and y. It's something called standard deviations and all. So just see that covariance correlation. If it is going to that positive, what will happen? It's going to be a positive covariance means when x increases, so y should increase. That the negative covariance means x increases when the x is going to increase, which is going to that should decrease. So it means negative covariance will be there. Okay. Correlation close to one means strongly or positively correlated. Correlation is close to minus one means strongly and negatively correlated. Like there, the scatteredness will be the more. It's a negative correlated. Okay. So this is if we talk about here, like strongly correlated. I know. So if we do the covariance simplifications also, covariance of x is equal to will become expectation of x into y minus expectation of x into expectation of y. I think this all you have done. I'm just giving the brief idea that how it will go and all. Then independence and covariance. When x and y are independent, so covariance will be the always zero. When x and y will be that what we can say that independent, so the covariance will be the always zero. However, so covariance of x and y is equal to zero. It doesn't mean that x and y will be the always independent. Always not independent. It depends. So that the next x is a random variable with the expectation of x is zero. So their all higher order will be the always zero. Okay. Then the covariance matrices is there. Similar way that I told we were having the variance that is the multivariance and all. So here also covariance of x I xi it will go. So we have to make the full matrices similar way that we have to make for the images. We'll be having to make the single pixel, double pixel, three pixel, and then it can go ahead with that. Okay. And then diagonal elements are simply the variances of the individual components. That is the covariance of x. It will be the variance of x and y. Okay. Then the last one, what we have, it's covariance of the two vector actually. It's a similar one only and affine terms and all. So can we go for some problems and all? Now we'll solve some problems and then we'll go ahead with this. Can anyone try to solve this problem? They have given probability. Consider three events A, B, and C given. A and B are the independent. B and C are the adjoint. They are saying to find out the what? Probability of C. Please someone try to do. Anyone is there? Okay, I'll check with that. Given P A union B is given 0.4. P B union C is given 0.5. P A into given 5. So that we all know that when two set of probability given, so P of A union B will be PA plus PB minus PA intersection B. Similarly, PB union C will be PB plus PC minus PB intersection C. Is it correct? Huh? Anyone is there? For independent event, P of A intersection B will be PA into PB. For this joint, B and C will be 0. So now we'll keep the value. I will go add from here. From the equation first, PB, we can get P A union B minus PA plus PA into PB. Is it? Because A and B are the independent. So PA union B that they have given 0.4 minus 0.2 plus PA is given 0.2 into PB. How it will look like? How much it came? 0.25. Is it correct? The first one. Anyone is there? Can we solve the second problem? We know that PB union C is equal to PB plus PC minus PB intersection C. So here we can get the PC because PB we all got already. PB union C minus PB plus PB intersection C because it's a disjoint. Okay. So P of C will be PB union C is the 0.5 given minus 2.5. So it becomes 0.25. I think it's clear. So now we have the third question is also there. No, P and C we got. Now they are going set to find out the P A union B union C. P A union B union C. So P A P B P C minus P A intersection B minus P B intersection C minus P A intersection C plus P A intersection B intersection C. As B and C are disjoint, so P A intersection B intersection C will be 0 in that case. So P of A union B union C will become PA plus PB plus PC, PA plus PB plus PC minus of A and B, it's independent event, PA into PB, BC will be the 0, this will be the 0, and P P into PC. So if we solve this one, so it will come 0.5. Okay, so now we have the third question what we have. Imagine if we have a mine detector device. Okay. The sensor present in the device is not perfect and can occasionally make the wrong detection. It may detect random object as mine or fail to detect on actual time with some probability. Consider the matrix M shown in table for representing the sensor is conditional detection probability, where row denotes the detection made, column denotes the true state of the particular region. So they're saying to find the unknown value of X in the matrix M. How can we approach this one? They're saying to get the what is the value of the X and Y. So how can we get it? So first one is the mine age percent. So probability of mine detected and mine percent plus probability of mine not detected into probability of mine percent will be 1. 1. So probability of mine is present, like mine is detected when the mine is present is the 0.8. Probability of the mine not detected plus y is equal to 1. So y is equal to 1 minus 0.8 will become zero point 0.2. So now the second case what we have, so when the mine is not present, now second case what we have, it's the mine is not present. So probability of mine not present. So probability of the mine detected mine present plus probability of mine not detected of mine not present is equal to 1. So in that case, x plus zero point 0.6 is equal to 1. So x will be zero point 0.4. So this is the answer will be point x is equal to zero point 0.4 and y is equal to zero point 0.2. So now the cost of the matrix quantify the loss associated with the miscalculation stance. Consider the following matrices. So in the table, it determine the cost of the reporting mine not detected. Mine not detected. So cost will be probability of mine not detected. Mine was present into cost. Mine not detected when it was present. Okay. Plus probability of mine not detected when mine not present into cost of mine not detected not present. So means what will be having 20 into zero point 0.2 plus 0. So it's become 4. So that answer is the 4. Now we'll go with the next question what we have. The question what we have considered two random variable x and y whose marginal probability density function are shown in the figure. Which of the following is not the sample xy that can be drawn from the joint distribution of the these two random variable? Can you just tell me what will be the answer for this? What will be the answer for this? We have given for the PDF of x minus 1 to 1. PDF of y is given minus zero point 0.5 to zero point 0.5. So we can go with the option A, zero point 0.1, zero point 0.4. So both can be drawn because we have the minimum if we can go with the zero point 0.5 to zero point 0.5. Even we can go with the zero point 0.4 to 4 also, but we can't go with the how much? Hmm? Maybe it's not sample xy that can be drawn from the joint distribution with the two, so these two random variables. We can't go minus zero point 0.5. That's less than that we can't go. So 0.75 we can't go. So that's the third option is the correct. And what is sixth option? They are saying if two random variable x and y are independent, which of the following sample x y is most likely to be drawn from the their joint distribution? For this, I'll explain again. Actually, let's say because they are saying minus 1 to 1, y having zero point 0.5 to zero point 0.5. So we can go in this range maximum of zero point 0.5 to zero point 0.5. But this zero point 0.5 minus 0.6, 0.75. So we can't go for this. So that's why we can't go for that because it's a joint distribution and all. So whenever we are going to, whenever we have the two independent random variable, so from the origin, we'll have the most likely will have both sampling of distributions. So 0, 0 is the answer for that. So now the seventh question, what we have, they are giving in a study of 1,000 patients, 4,000 patients have the hypertension, 6,000 patients have the diabetes. Among the hypertension patients, 250 also have the diabetes. So, like they have given how much, like n is equal to 1,000, and patient with hypertension, it's x is equal to 1, 400. Y is equal to 1. So n of y is equal to 1, they have given 250. Then after, they are saying patient both hypertension and diabetes, like n is equal to x is equal to 1, y is equal to 1. How much? 250. Sorry, this is the 600. So they are saying to find the conditional probability p is equal to y is equal to 1, when the already, what you can say that that is, what is the probability of having diabetes when the already the patient have the, what you can say, like that the hypertension they have already. Okay, so what is the formula for this? Can anyone tell? This is the case of conditional probability actually. It will be probability of y is equal to 1, x is equal to 1 will be probability of x is equal to y is equal to 1 by total probability of when already they have. So this is 250 by 400.625. So that option C will be the correct option. I think it's clear. We have that three more questions are there, not more than that. We'll go. We'll wind up in the 10 minutes and then we'll go. So they have given the one question they have given, like it's a given x given, y given, probability of x and y also given. One 1.3, 2.2, 130, 1.1, 2.2, 3.2. Okay, so they are going to calculate the covariance of x and y. So we know that covariance of xy formula expectation of x y minus expectation of x expectation of y. So first we calculate marginal property. What you can say? Probability. X is equal to 1. So P of x is equal to 1 will be zero point 0.3 plus 0.2 plus 0.1. Like it will become 1, 1, 1. So 0.5. P of x is equal to 2. X is equal to 2. 0.5. 0.1 plus 0.2 plus 0.2, 0.5. So now expectation of x will become a summation of x px. How much? 1 into 0.5 plus 2 into 0.5, it will become 1.5. Okay. So now we'll go with the marginal like probability. Y is equal to 1. So P of y is equal to 1 will become y1 is become 0.4. Y is equal to 2. P of y is equal to 2. It will become how much? Y is equal to 2.4. P of y is equal to 3 will become pi is 3. How much? 0.2. Okay. So expectation of y will become y p of y. So y how much is there? 1 to 3. 1 into zero point 0.4, 2 into zero point 0.4 plus 3 into zero point 0.2. So that the answer will be 1.8. Now the expectation of x and y, how we'll get it? we'll get how 1 is to 1 into 0.3. That all summation will be there. We take one page extra. So it will come 2.9. So now covariance of xy will become expectation of xy minus expectation of x, expectation of y will become 2.9 minus 1.5 into 1.8.2 will be the answer. So now what we have, some one more question is there. Last question. They have given a discrete that the random variable x is equal to 1, probability of x is equal to 1, they have given 0.2, probability of x is equal to 2, they have given 0.3, probability of x is equal to 3, they have given 0.3, probability of x is equal to 4, they have given 0.2. So expectation will be how much? So 1 is to 0.2 plus 0.3 into 2 plus 3 into 0.3 plus 4 into 0.2. Okay, so it will come 2.5. And now 10th one is the variance of x. Expectation of x square minus of expectation of x square. So variation of expectation of x square will become x square px. So 1 into 0.2 plus 4 into 0.3 plus 9 into 0.3 plus 16 into 0.2. So it came 7.3. 7.3 minus 6.25. It came 1.05. So this is the answer. I think it's clear from here, na? Hello? Can anyone answer this? Hello? Anyone is here?
Yes, sir.
Yeah, so till today, like we have discussed the probability and all. So the next class will be seeing that computational mechanics and all, and we'll see some optimization problems and all. So hopefully, if you have any doubt and all, so that all materials I'll keep in the drive link, or even that you can go to that dashboard of the PM that no that is a NPTL, so you can get it there. And in the coming classes, if you have any doubt, please ask. That we'll try to solve first, and then we'll go ahead with that. Any doubt is that till now?
No, sir.
Okay, then shall we wind up?
Okay, sir.
Okay, then thank you.
Thank you, sir. I think.